Recording in progress.
In this video, we'll work with Kirchhoff to determine currents. So now, given a circuit diagram, 3 loops, we are asked to determine I1, I2, I3 using Kirchhoff's law. So I'm going to explain and show you how to use Kirchhoff's to determine and derive the formulas and how to write the direction of a current and voltages. So first thing you need to know before Kirchhoff's it's simple and straightforward. So now we want to determine I1, I2, I3. I want to determine I1, I2, I3. So I will need to know my directions and draw them for currents. So now I want to start with I1. I1 meaning I will work in loop 1. So since now I want to start with I1 and I will work in loop 1, I will check, I'm given a direction in loop 1. So since I'm given direction, this direction determines a direction of a current. So that means the current in I1 is going to end this junction. And the current for I2, it will leave that junction. And the current that will flow through the resistor in the middle, it will go up. So this is I1, and this will be I2, and that will be I1, and that will be combination of I1 and I3. We don't know whether it's minus or addition, but then it will be combination of I1 and I2. The current that will flow through 25 ohm, this 25 ohm. So now, since there's a video that explained how to get the formula for current in the middle of the resistor. So now, since I see the junction, how it's determined, and then I can see I2 and the resistor, the current that will flow through to 12 ohm, 25 ohm. They're leaving a junction since I1 is the one that is entering a junction. So that means the current that will flow through 25 ohm is I1 minus I2. Why? That is because I1 is entering a junction. Therefore, the current through 25 ohm and I2, they're leaving a junction. So that means I1 is equals to I2 plus the current that will flow through 25 ohm. That this is because this is the scenario of KCL, which is Kirchhoff's law, state that the current that is entering a junction is equals to a current that is leaving a junction. I in is equals to I out. So which currents are leaving a junction? Which currents are entering? So here, I2 and the current that will flow through 25 ohm, they are leaving this junction. Then I1 is the one that is entering. That means the sum of I2 and the current through 25 ohm, they equal to I1. So from there, if I want to make the current through 25 ohm substitute of the formula, is going to be I1 minus I2. So I1 minus I2 is the current that will flow through 25 ohm. So you need to know how to determine the current for the common resistors. The resistors that join the 2 loops. The resistors that join the loops of your circuit. So you need to derive or know how to derive the formulas for the resistors that join your loops. If you can determine the formula for resistors that join the loops, you will be able to derive your formulas. So now I want to derive a formula for loop 1. I was just explaining how to derive or know your formula for your resistor in the middle. So we use this scenario, I in is equals to I out. So now I want to determine or derive a formula for loop 1. I want to derive a formula for loop 1. So since I want to derive a formula for loop 1, first thing I will check whether my V source is positive or negative. How do you check your V source is positive or negative? You are given a direction in your loop. I'm given a direction in this loop. In this loop, the direction is from left to right. It's direction that I'm given. Therefore, I will check using my V source whether it's following the direction that I'm given in the loop or it's opposite to it. So now, direction to know my direction of the V source, I know what direction of a battery start from positive to negative. So meaning my direction will start from positive to negative. So that means my direction will start from right to left for this battery. And my direction for the one that I'm given in the loop is from left to right. So that means the direction of the loop of the battery and the direction that I'm given in this loop, they're opposite to each other. So that means my V source will be negative. Therefore, it's equals to. That means my V source will be negative. Therefore, it equals to. Now, the sum of the voltages across the resistors in this loop, they equals to my V source. The sum of the voltage across the resistors in this loop, they equal to my V source. Then I will say is equals to 15 I1. I1 is the current that will flow up through 15 ohm plus 10 I1 again plus 25. Current that will flow through 25 is I1 minus I2. Therefore, the equation for loop 1 is going to be 25 I1 minus 25. 50. It's 50 I1 minus 25 I2. So that's the equation for loop 1. So to determine or derive the equation for loop 1, you need two things there's two things you need to know. You need to know whether your V source is positive or negative. And therefore, you need to check your Mickel resistor or the resistor that join your loops. If you're working in loop 1 or loop 2, know how to derive the formula for that. Know how to derive a formula for current that will flow in that resistor that is in the Mickel, the resistor that joins your loops. So if you can derive the formulas, then you'll be able to derive the equation for loop 1. So what was important here? The important part was to derive the formula for current that will flow in the resistor in the Mickel, and then was to know whether the V source or the voltage in this loop is either positive or negative. Therefore, from there we can derive the equation. And therefore, what you need to know, just know that the sum of the voltage across your resistors in that loop, they equal to your V source. So just equal your V source to the sum of your resistors with their currents, then they'll give you your equation for loop 1. So now, equation for loop 2. So now, since I want to derive equation for loop 2, I have a battery in loop 2. It's here, which is 28 volts. So if I check the direction of that battery, remember, the direction of a battery we start from positive to negative. That's how we determine the direction of a battery. It's from positive to negative. So if I draw a direction of a battery, it's positive. It's from positive to negative. It's from left to right, and the direction that I'm given in loop 2 is also from left to right. So that means the V source in loop 2 is positive. Then I'll write 28 is equals to, it's positive. So the current that will flow through 12 ohm and 12 ohm, the two resistors in loop 2 is I2, and then the current that will flow through 25 is combination of I1 and I2. So I will say 12 I2 term plus 12 ohm again I2. Therefore, now I want to you know that the sum of the voltages across 12 ohm, 25 ohm is equal to 28. So that means I need to make 25 ohm positive. And I already have equation, which is I1 minus I2. So how will I make 25 ohm positive? And then if now I want to get I don't know whether it's positive or negative. Remember, the direction for loop 2 is going from left to right, and the current that will flow through the 25 ohm is going from right to left. So that means to determine whether this is negative or positive, we check its current and its current direction and direction were given in that loop. So now the direction that I'm given in loop 2 is going from left to right, and the direction the direction of a current through 25 ohm is from right to left. So since I'm saying it's from left to right, meaning what it will go like this through 25 ohm, then direction in loop 2 is like this. So this is direction of currents. So now since they are opposing, so that will make 25 ohm negative. So that will make 25 ohm negative. Therefore, to simplify the formula, is going to be minus 25 ohm I1 plus 49 I2. So why is here now negative 25 I1 minus I2? It's because the current that is going to flow through 25 ohm is going up, while the direction of a current in loop 2 is going down. Why I'm saying it's going down is because we're given the direction in loop 2. So this direction is direction of a current in loop 2. It will go down. It's the direction of a current in loop 2. It will go down while the direction of a current that will throw through 25 ohm is going up. So since they're opposing, that will make 25 ohm negative. Why is positive in loop 1? In loop 1 is positive because the direction of a current in loop 1 is going up. This direction we're given in loop 1 is going up, and the direction of the current that is going to flow through 25 ohm it is also going up. So that's why I'm saying it's positive, because they are both going in the same direction. If they're not going in the same direction, it's negative. Same direction, positive. So that's how we derive equations. So this question is for loop 2. Now let's derive the one for loop 3. For loop 3, I will have to check whether my V source are negative or positive. So if you check, the direction of 9 volts is opposing the direction that I'm given in loop 3, and the direction of 28 volts is also opposing the direction that I'm given in loop 3. So that will make them negatives. So it's going to be negative 9 minus 28. They're equal to I3. Remember, this is I3, 35 I3 plus 30 I3. Therefore, the final equation is minus 37 equals to 65 I3. So this equation is for loop 3, is for equation 3. The equation for loop 3. So it's simple and straightforward. Since we don't have a resistor in the middle, so the current it's a voltage source. It doesn't share a current with a meaning that means a voltage source is a voltage source. We can't say there's a current, there's I2 in 28 volts. It's just 28 volts. So equation for loop 3 is going to be 65 I3 only. So now let's use matrices to find I1, I2, I3. So let's use matrices. So now since we have 3 equations, we're going to use 3 by 3 matrices. So loop 1 is row 1, loop 2 is row 2, loop 3 is row 3. So it's going to be 50 plus 50 minus 25, 0. Why 0? Because there is no I3 in loop 1. So that means the value here is going to be 0. Then 25, this is for loop 2, minus 25, 49. Since I don't have a I3 here, the value will be 0. So for equation 3, for loop 3, I'll have 0 here, I don't have I1 and I2 on the equation of I3 of loop 3. I'll have 0 again for I2. Therefore, there will be 65 for the resistor in I3. Then that will be I1, I2, I3 equals to minus 12, 28, minus 37. Therefore, use a calculator, enter these numbers. From there, you'll get your current values. I found my I1 is equals to 61.37 milliamperes, and my I2 is equals to 602.74 milliamperes. I3, and my I3 is equals to minus 569.23 milliamperes. It's milliamperes, guys. Don't forget to put A for milliamperes. So that's how we derive equations and how to use Kirchhoff's law to determine I1, I2, and I3. That's how I use them to get the currents. I can say my steps on how to use Kirchhoff. I will first find the formulas or derive formulas for the Mickel resistors. Mickel resistors are resistors that join the loops. Those are my Mickel resistors. I'll first derive the formulas for them. I'll have to know the current that will flow through them. I will have to know the equation for the current that will flow through them. From there, I'll need to know my visuals, whether are positive or negative. I'll use the direction that I'm given in my loops to check whether they are positive or negative. Therefore, from there, I'll derive the equations using KVL and KCL. So this was KCL here. This was KCL. KCL is Kirchhoff current law. KVL is Kirchhoff voltage law. KCL to determine the formulas or to derive the formulas of currents. Then KVL is to find the equations in loop 1, loop 2, loop 3. So that's it for this circuit. We were asked to determine I1, I2, and then that's how we derive a formula, and that's how we use matrices to we plot these equations in matrices. From there, use a calculator to get your currents. That's how I use Kirchhoff. So let's go to the next example and see. Again, we have this kind of circuit diagram. We were asked to determine I1, I2, I3 again. So I1, I2, I3. So we are asked to determine I1, I2, I3 again. So the circuit is kind of similar to that one, but they're not the same because they're not the same on how they draw them. So they're not the same, but then it's through loops. The schematic is not the same, but they're both 3 loops. So now again, I want to determine I1, I2, I3. My steps, first and foremost, I will start checking the current that will flow through 3 ohm, because 3 ohm is the resistor that join I1 and that join loop 1 and loop 2. And I will derive formula for 3 ohm. Again, 3 ohm, this 3 ohm, it also join I3 and I1. It joins loop 1 and loop 3. 4 ohm, it also joins loop 2 and loop 3. So the current, I will start drawing the direction of a current. I'm already given a direction in this loop, so I just need to know the direction of the current on how they will flow. So this will be I1 and that will be I2. So that means the one that will go down is I1 minus I2. So here I'm given direction again. So I want to determine the current that will flow through 4 ohm. This is going to be what I2. Why is in this loop the current must flow in this direction? This is going to be I2, then I1. That will be I1. That will be I1. Then sorry, I made a mistake. So for 4 ohm, I want to know the current that will flow through 4 ohm. Remember, I2 is the one that will enter this junction. I2 is the one that will enter this junction. Then I3 is going to leave that junction with the current that will flow through ohm. We don't know it. So that means the current that will flow through 4 ohm is I2 minus I3. Therefore, we had a resistor here, which is 3 ohm. Now, this junction, I3 is going up. It's the one that will enter the junction. Therefore, I1 is leaving that junction. Then we don't know what's the current through this resistor. So that means the current through the resistor is going to be I3 minus I1. So now let's start deriving the equations for loops. Which is KVL. For loop 1, I will check my V source. The direction of my V source always starts from positive to negative. From positive is going up. My direction of a V source is going up, while the direction that I'm given is also going up. So they're going in the same direction. So that means my V source is positive, which is going to be 11 volts is equals to through 5 ohm and 3 ohm. The 3 ohm, for this 3 ohm and this 5 ohm, the current is I1. They're the same. So it's going to be 3I1 plus 5I1 plus 3I1 minus I2. So now I want to know, I already know the current that will flow through this 3 ohm. The current that will flow through this resistor. The current that will flow through this resistor is I3 minus I1. Why? Because I3 is the one that is entering this junction. Then I1 and the current through this resistor, they are leaving that junction. So that means the current through this resistor is I3 minus I1. Okay, it's I3 minus I1. So the current of this resistor is going from left to right. Its direction of a current is this one. Is this one. Is going from left to right. And the direction that I'm given in loop 1 is from right to left. So that means the direction of a current through 3 ohm is opposing the direction that I'm given in loop 1. So that will make it minus. That will make it negative. So that will be negative 3 I3 minus I1. Why is negative? It's negative because the current that will flow through that resistor is opposing the direction that I'm given in loop 1. How did I determine the direction of a current? I3 is the one that will enter this junction, and I1 will leave that junction. And what will happen? The current up. What about the current through the ohm? Is the one that will also leave the junction. So that makes the formula of the this resistor is going to be I3 minus I1. So now I'm working in loop 1. I want to derive equation for loop 1. It will make it minus 3 because it's opposing the direction that I'm given in loop 1. So now let's simplify our formula. It's going to be equals to 14 I1. The ones with same variables, I add them, and then the ones with not same variables, I do not add them. So I just leave them like that. So minus 3 I2 minus 3 again I1. Sorry, I3. So the formula is 14 I1 minus 3 I2 minus 3 I3. That's the equation for loop 1. Then for loop 2, again, for loop 2, in loop 2, there's no voltage source in loop 2. So the V is equals to 0. The voltage in loop 2 is equals to 0. That means the voltage is across 8 ohm, 3 ohm, 4 ohm, 3 ohm. Again, they're equals to 0 volts. So in loop 2, I have 8 I2 plus 3 I2. Then now, okay, again plus 4 I2 minus I3. Then what about these 3 ohm in the middle that joins I1, loop 1 and loop 2? So for 4 ohm, I add, why I add is because this direction is the same as direction that I'm given in loop 2. So now, for 3 ohm, I'm going to subtract. Why I'm going to subtract is because this direction for loop 3, for 3 ohm is going down. The direction is going down of 3 ohm. While the direction I'm given in loop 1, in loop 2 is going up. So direction in loop 2 is going up. While the direction the current through 3 ohm, this direction is going down, and the direction in loop 2 is going up. So now the direction are not the same, they're opposing each other. So that will make it minus. So I will subtract 3 I2 minus I1 minus I2. 0 is equals to minus 3 I1. I add the ones with same variables, then I arrange them according to I1, I2, I3 plus 18 I2 minus 4 I3. So that's the equation for loop 2. That's the equation for loop 2. Then the equation for loop 3. The equation for loop 3. In loop 3, I have a voltage source. In loop 3, I have a voltage source. When I have a voltage source, I will first check the direction in loop 3 is going from left to right. And then if I check from my V source, which is 9 volts, this direction is also from left to right because it's going down. If it's going down, it's like that. So it's going from left to right. So directions are the same. So that will make it positive V source. So I'll say 9 volts is equals to 3 I3 plus 2 I3, 3 I3 plus 2 I3, 3 I3 plus 2 I3. So now I have 3 ohm and the 4 ohm that joins the loops. So for my 3 ohm, it's going to be positive. Why? The current that's going to 3 ohm, this direction is the same as the direction that I'm given in loop 3. So plus 3 I3 minus I1. So for the direction of the current through 4 ohm, it's opposing the direction that I'm given in loop 3. When you derive the equations or of the loops, when you're in loop 1, you focus in loop 1. When you're in loop 2, you focus in loop 2. When you're in loop 3, you focus in loop 3. But then I've used loop 2 to get the direction of the current. Now, since I'm in loop 3, is now opposing, that means it will make it negative. So for 4 ohm is going to be negative 4 ohm. Why? Because the current through 4 ohm is going from right to left. This is the current through 4 ohm. The current through 4 ohm is going in this direction, while the current in loop 3 is going from left to right. So they're opposing each other. That's why it's negative 4 ohm. I2 minus I3. So then the equation, if I simplify the equation, it's going to be minus 3 I1 minus 4 I2 plus 12 I3 plus 12 I3. Therefore, I'm going to use matrices to get I1, I2, I3. Loop 1, row 1. Loop 2, row 2. Loop 3, row 3. I have 14 minus 3 minus 3 for equation 2 minus 3, 18 minus 4. For equation 3, row 3 minus 3 minus 4, 12. I1, I2, I3. 11, 0, 9. Therefore, use a calculator to determine the current. So I've explained in some videos I've uploaded. Please go and check on how to use the matrices to get the values. 14 minus 3 minus 3, 11 minus 3, 18 minus 4, 0. Please guys, double check. When you use a calculator, double check whether you're entering correct values. Because when I use matrices, one mistake, everything will be wrong. That's a boring part about matrices. Because if you enter a wrong number, wrong value, will affect your values. 14 minus 3, 3, 11 minus 3, 18 minus 4, minus 3 minus 4, 12. I1 is equals to 1.137 amperes. I2 is equals to 0, 453 amperes. Amperes. And I3 is equals to 1,185 amperes. So that's how we use Kirchhoff's law to determine currents in each loop. Guys, if you did understand and benefit something from this video,